Variable expressions and sequences. A sequence may be infinite or finite. To see sequences, one must just look for the patterns in the numbers. Okay, so the first thing we're going to do is just write down the first four terms of the sequence. We're given an equation, and we want to write the first four terms. So term 1 we will write as a sub 1, and that's going to be 3 plus negative 1 to the first power, because wherever you see an n, you're just going to put in 1. So that's going to be 3 plus negative 1 to the first power, which is 2. So the first term in the sequence is 2. Then we go to a sub 2. So 3 plus negative 1 squared is going to be 4. A sub 3 is 3 plus negative 1 cubed, which is going to be 2. And a sub 4 equals 3 plus negative 1 to the fourth, which is 4. So the first four terms of the sequence is 2, 4, 2, 4. So you can kind of see the pattern that seems to be arising. And the next example here, we have a sub n equals 3n minus 2. So to find the first four terms, a sub 1 equals 3 times 1 minus 2. 3 times 1 is 3, minus 2 is 1. A sub 2 equals 3 times 2 minus 2, which would be 3 times 2 is 6, minus 2 is 4. A sub 3 is equal to 3 times 3 minus 2, which is 9, minus 2, which is 7. And a sub 4 equals 3 times 4 minus 2, 12 minus 4, 12 minus 2 is 10. So the first four terms of the sequence are 1, 4, 7, and 10. And that's the pattern. To determine a sequence given a set of numbers, one must find the nth term, or the generalized equation that demonstrates the pattern. But in order to do that, you need to first just describe the pattern to yourself about what is happening with the numbers. So in this first example, we have 1, 3, 5, 7. Okay, so the pattern that should jump out at you is that they're all odd numbers. So somehow our generalized equation would have to deal with odd numbers. But another thing we need to take into account is where the pattern of odd numbers begins. Well, the pattern begins at 1. So it's all odd numbers starting at 1. Alright, just being able to describe the pattern will help you later when we are actually trying to find explicit formulas for the sequence of numbers. In the next example, we have 2, 5, 10, 17. Okay, this one may be a little bit harder to actually see. We can't just say they're all odd numbers because it's going even, then odd, then even, then odd again. So we don't really know if that's the pattern. But could we just add 3? 2 plus 3 is 5. But then if you add another 3, that doesn't work. So you can't go 5 plus 3 to get 10. So that didn't work. But the pattern seems to be add 3, and then we are adding 5, and then we are adding 7. So that could be a pattern in there. But if you also think about the other things we can do with numbers, we can square numbers. If we think about our perfect squares are 1, 4, 9, 16, 25, and so on. Those are perfect squares. Alright, so if those are perfect squares, we aren't quite at the perfect square, but if we just added 1, 1 plus 1 is 2, so that gives us our first number. 4 plus 1 is 5, so that gets us to our second number. 9 plus 1 gets us to 10. 16 plus 1 is 17, so my guess in the next one would be 25 plus 1, which is 26. The next number would be 26. So my guess on this pattern seems to be square, perfect squares, plus 1. And this would help us to actually find the equation. So it's going to take a lot of just trial and error and see what's working in order to actually find the patterns. So as you can see, maybe two different patterns would work. Maybe this pattern that we had here would work somehow if we could work out how to jump in our intervals up by 2 each time. But we just have to think about it a little bit more. So those are your notes on variable expressions and sequences. Go through the practice problems and then prepare for a quiz over this material. You're going to want to be able to write down different numbers and sequences and be able to identify what the patterns are in a general sense.